Hello, hi and Assalamualaikum warahmatullahi wabarakatuh. We are going to present to you about the chemical kinetics in the preservation of meatballs. Since I'm the first speaker, I'm going to present to you about the introduction, which include what is chemical kinetics and how chemical kinetics can relate to the preservation of meatballs. So, as I promised, what is chemical kinetics? Chemical kinetics involve the experimental study of reaction rates to infer about the kinetics mechanism for mechanical conversion of reactant into products. Then, chemical reaction occurs when sufficient energy is brought to the molecules of one or several compounds in proximity of each other, producing a collision that results in breakage or formation of bonds among the atoms in those molecules. So, how about the relation between the chemical kinetics and the preservation of meatballs? First of all, multiple chemical reactions take place in the foods, while some reactions are necessary to produce the compounds that are responsible for flavor, texture, and also nutritional value. But others might result to the spoilage to the food. Thus, the study of chemical kinetics plays an important role in the preservation, preparation, and also the analysis of food. For food preservation, it is necessary to determine the optimal condition which required to decrease the rate of degradation, which is to decrease the rate at which certain compounds react within the food during the storage. In other words, it is necessary to find processing conditions that can maximize the rate at which desired reaction occur, and thus we can minimize the undesirable reaction to occurs.
The first application is the application of kinetics in food storage.
Subjecting meatballs to low temperature transition them from fresh state to solid frozen state. This preservation method is done to maintain the quality, texture, and flavor of the food for later consumption. During freezing, enzyme is slowed but not stopped, leading to potential changes in the flavor, texture, and color over time. Understanding the chemical kinetics of enzyme catalyzed reaction can help to preserve the quality of meat during storage. Chemical kinetics of meatball freezing. Chemical kinetics of enzyme catalyzed reactions helps preserve meat quality during freezing by controlling the speed of reaction by several factors. The first factor is temperature. The lower the temperature, the lower the reaction rate. Adjusting the freezing temperature can influence the enzyme activity. Lower temperatures generally slow down enzymatic reactions, helping to preserve the meat. The second factor is concentration. Reducing the concentration of substrates can reduce reaction rate. Modulating the concentration of substrates can impact reaction rates. Controlling substrate levels contributes to managing enzymatic reaction. And another factor is pH. Maintaining an appropriate pH level during freezing can help ensure the enzyme work efficiently without causing unwanted changes in the meat.
That each food has their own optimal storage condition. This food temperature monitoring chart shows how long can each food be stored.
Thank you, Sarah, for the great explanation. Today, I would like to explain about the application of the kinetic and the impact of the preservative on microbial growth. For the meatball preparation is more than just a culinary art. It is a science-governed kinetic. Just as in chemical reaction, we observe the rate at which reaction occur during the preparation process. Kinetic in the context of the meatball preparation refer to the study of the reaction rate between ingredients as preservative like sodium nitrate and CMC, carboxymethylcellulose. It is the speed at which our components interact during the mixing process. The primary function of the kinetic in the meatball preparation is to ensure uniformly. We want every part of our mixture to react at optimal speed, creating a homogeneous blend. The important process is the reaction rate between ingredients, ensuring a homogeneous blend for optimal meatball preparation. First, preservative introduction. Meet our key player like sodium nitrate and CMC. They acting as guardian and inhibit microbial growth, extending meatball shelf life. First step is preservative impact. Assumption gather the ground meat, breadcrumbs, spice in the mixing bowl. The magic begins as each ingredient play a crucial role. Step 2, combine the ingredient. Ground meat, breadcrumb, and spice unite for the symphony of flavor. Step 3, add preservative like sodium nitrate and CMC. They step in to protect our meatball. Step 4, kinetic at work. Preservative mingle and kinetic reaction efficiently reducing the microbial growth. Step 5, effective preservation. Optimized reaction lead to the preservation, keeping meatball safe without compromise. Step 7, cooking process. The meatball is ready to serve. As you can see at the screen, they have an image which is the chemical interaction create a formidable defense against the microbial activity. And then they also have microbial growth graph, which is the preservative impact ensuring a decline in microbial activity for a several longer lasting product.
Now we move on to the safety considerations during the preservation of meatballs. The first and foremost is by using the right preservative concentration. It is crucial when making meatballs to ensure food safety and extend their shelf life. Preservative play a vital role in preventing the growth of harmful bacteria, yeast, and molds that can cause foodborne illness and spoilage. The second one is by maintaining the appropriate concentration of preservative. You can inhibit the growth of microorganisms that may be present in the meat or introduced during the preparation process. This helps to ensure that the meatballs remain safe for consumption over an extended period. The third one is hygiene. Maintaining proper hygiene is crucial. Wash your hands thoroughly with soap and water before handling any ingredients. Additionally, ensure that all utensils, surfaces, and equipment used in the preparation process are clean and sanitized. Next, let's talk about the potential risks that need to be considered to ensure food safety. Some of the risks include microbial growth. If the meatballs are not properly preserved, there is a risk of microbial growth. Bacteria, yeast, and molds can multiply rapidly in the meatballs, leading to foodborne illness such as Salmonella, E. coli, or Listeria. Second, inadequate preservation. If the preservative or the concentrations are not used correctly, they may not effectively inhibit microbial growth. This can result in the meatballs spoiling quickly and become unsafe for consumption. And lastly, cross-contamination. During the preservation process, there is a risk of cross-contamination if proper hygiene practices are not followed. This can occur when utensils, surfaces, or hands come into contact with raw meat or other contaminated ingredients, leading to the transfer of harmful bacteria. Last but not least, regulatory compliances. Here are a few examples of regulations governing the use of preservatives in meat products. Number 1. United States. In the United States, the Food and Drug Administration (FDA) and the United States Department of Agriculture (USDA) regulate the use of preservatives in meat products. They establish regulations for meat and poultry products, including guidelines for the use of preservatives. Number 2. European Union. In the European Union, the use of preservatives in meat products is regulated by the European Food Safety Authority (EFSA) and the European Commission. The EFSA evaluates the safety of food additives, including preservatives, and provides scientific advice to the European Commission. The European Commission then established regulations and maximum permitted levels for preservatives in meat products. Number 3. Codex Alimentarius. The Codex Alimentarius Commission, established by the Food and Agriculture Organization (FAO) and the World Health Organization (WHO), develops international food standards, guidelines, and codes of practice. The Codex Alimentarius includes guidelines for the use of food additives, including preservatives, in various food categories, including meat products. Therefore, in summary, chemical kinetics plays a significant role in meatball preparations by influencing various aspects of the cooking process. Understanding the principles of chemical kinetics is crucial for achieving desired texture, flavor, and overall quality of meatballs. The first one, chemical kinetics, governs the Maillard reaction, which is responsible for the browning and the development of desirable flavors in meatballs. This reaction occurs between amino acids and reducing sugars at elevated temperature, resulting in the formation of complex flavor compounds. The second one, chemical kinetics, helps determine the optimal cooking time and temperature of our meatballs. Different reactions occur at different rates depending on temperature, and understanding these kinetics allows for precise control over the cooking process. The third one, meatballs often contain emulsions such as fat and water-based ingredients. Chemical kinetics influences the stability of these emulsions during cooking. Understanding these kinetics of emulsion formation and breakdown helps in selecting appropriate ingredients and cooking techniques to maintain the desired texture and prevent separation. The last one, chemical kinetics also plays a role in preserving meatballs. By understanding the kinetics of microbial growth and spoilage reactions, preservatives can be added at the right concentrations, and cooking methods can be employed to inhibit microbial growth and extend the shelf life of meatballs.